Few-shot weakly supervised object detection via directional statistics. In the few-shot weakly supervised object detection problem, we are given few images in the support set. These support images are only labeled with image level labels, but we are asked to detect these objects in the query image. Note that none of these objects has been seen before and they are all novel. To solve this problem, we first localize common objects among support images with the same image level label. The Common Object Localization module is run separately on the images from each of the novel classes. For a novel class C, the input to the Common Object Localization module is a set of normalized feature vectors from the images of class C. Then, an expectation-maximization algorithm of these feature vectors determines the direction parameter of one misses feature distribution on the unit sphere most likely to favor a common object representative from each image. The closest feature from each image identifies the bounding box containing the common object. A distribution for a background class is also trained, using the base dataset to steer the Common Object Localization unit away from the selecting background objects. Once the novel objects are found by the Common Object Localization module, their bounding boxes are used to train a box classifier for each novel class C. The classification is done by a two-class classification algorithm, once again working on normalized feature vectors. These bounding boxes and their associated features are labeled as either positive or negative for containing the object of the novel class or not. The positive bounding boxes are those that are determined by the Common Object Localization module to contain the common object from class C, and the negative samples are chosen from proposals selected from the images of the other classes. In this way, the classifier for class C is trained to distinguish features corresponding to bounding boxes containing an object of class C from those that do not. We evaluate our algorithm in the task of Common Object Localization shown in the table on the left side and few-shot weakly supervised object detection in the table shown in the right side. For the Common Object Localization task on the COCO dataset, we compare ourselves with Silco and Greedy Tree to a state-of-the-art for these tasks for 5 and 10 shot support set size. And in all these cases, our algorithm outperformed the state-of-the-art. To the best of our knowledge, there is no other weakly supervised object detection in the few-shot setting in the literature. So we compare our algorithm to MISVM, which is designed for large-scale weakly supervised object detection. We realized that in both Pascal and COCO dataset, MISVM usually overfits when the training set size is small, and we can outperform that algorithm with large margin in all the cases. Please refer to our paper for more experiments. To visualize how our algorithm works, we show a qualitative results here. In the support set, there are 5 novel classes and there are 5 images from each novel class. And we also have 4 different query images, and we show the results on each of them separately. As you can see, our algorithm can detect the novel classes in the query images successfully without having their bounding box annotation in the support set.